So good evening, everyone. Welcome back to the Gen AI webinar. Today, we'll be talking about exploring Llamaindex framework. And let's first talk about what are the raw data sources, right? So let's start by understanding the kind of data we deal with in the real world. It comes from everywhere, be it files, databases, APIs, even SaaS platforms, software as a service platforms like Google Drive or Notion. This raw data is usually messy, unstructured, and it's pretty hard to use directly in the AI applications. So what happens is we have something called as loaders. To handle this kind of unstructured data, we use something called as data loaders. These are Python classes like simple directory reader or beautiful soup web reader. These basically will open your data sources, read the content, clean it, and normalize it. Then what is the result? The result that we get will be neat document objects that will contain the actual content along with helpful metadata, like where the data came from or when it was collected, etc. These kind of things. So you can see Python loader classes here, like simple directory, Notion page reader, Slack reader, SQL database reader, beautiful soup web reader. These are all the classes that we have and description. And then once the loader takes the data, this unstructured data, and collects it, we will be doing certain pre-processing on those data. So we need to select the appropriate loader class in Python. And then internally the loader will, what it will do is it will open the data source. It will read that raw content of the data. It will clean and normalize the data. And this clean data will be wrapped into some sort of a structured document object, like a metadata kind of a thing, right? So this is what the document objects will do. They basically try and understand where the data is coming from, when it was collected, etc. So that's about the data loaders. Next comes the chunking function. So basically, once we have the structured documents ready with us, we need to break them down into smaller logical parts. These smaller logical parts are nothing but chunks. So this process is called as chunking altogether. So each document will go through a parser class. Okay, this will break the document into some logical smaller parts. Okay, maybe based on a sentence, based on a graph, paragraphs, or based on some token lengths, it is going to split the huge text document into smaller chunks. And then the metadata, such as source, line numbers, page numbers, all of these are attached to each chunk, transforming it into a node. So Llamaindex uses node parsers to divide the document into sentences, paragraphs, or fixed token lengths. Each of these chunks or nodes will retain the metadata like the source file, line number, or page number. And this will make it easier to trace it back later. Right? So these are the kind of different parsers that we can use, parser modules which are provided by Llamaindex framework itself. You can have a text node parser, sentence splitter, token text splitter, all these things. Text node parser could be a general parser which splits the document into nodes. Then sentence parser, basically it splits the text into sentences, okay, or groups the sentences in a certain way, like using a chunk. Then token text splitter, what it does, it splits based on the token count itself, right? This is useful for LLMs with token limits. For example, OpenAI, there's some sort of token limits when you're sending some text, right? That beyond these many lines in one go, I cannot read and understand or comprehend. So this is the kind of a thing. And what node will do, it will take the metadata and the chunk along with it. Okay. Now, to make this data searchable by AI models, we need to convert these chunks into some numerical vectors, because obviously the AI models do not understand simple English language. So we need to break these text chunks also further into some vectors, into some numerical vectors. Okay. So these vectors will be stored in some structures called as indexes later on. And Llamaindex will give you several options. Using Llamaindex, you can get into vector store index, list index, tree index. Each of these indices will basically have some sort of uh, what do you say? Depending on what we want to search and what kind of data we want to retrieve, we can do this, right? And OpenAI embedding, different kinds of embedders are also there. So we have OpenAI embedding, Cohere embedding, Hugging Face embedding. OpenAI embedding will convert the text into embeddings using the OpenAI model. So you have this text embedding OpenAI model of ADA 002. Then Cohere embedding, this will use some Cohere's language models in order to generate a semantic vector representation. Hugging Face, again, transformer models, it will make use of your BERT, Mini LM, all these things. Then we also have a lot of different embedders like this, like a vector store, FAISS, again, this is pretty used, popularly developed by Facebook. Then we have Chroma database, right? So we have simple open source vector database with fast local storage and querying. Then we have Pinecone embedders where these are fully managed by Cloud Vector databases itself. VV8 is another example. Quadrant, okay. This is also Rust-based high-performance vector database for large-scale semantic search applications. So several things are there which can be used for this particular purpose. Okay. Then comes indexes, okay. So basically the indexes will allow you to organize the data efficiently so that when a user asks a question, we don't have to search the entire data set. Rather, we just have to look at the right place. Think of it like a smart library catalog where it points us exactly to the page which contains the answer instead of flipping through all the pages, entire book, and then getting an answer out of it, right? So it takes time. So in this text, what happens? The parsed and embedded data, the nodes and the vectors, they will be organized into some specialized data structures called as indexes. And we are using Llamaindex classes like vector store index, list index, tree index, all of these things. Vector store index most commonly used to retrieve relevant data chunks using similarity search. List index, this will store the nodes as a form of a list. So whenever you're going through any sequential task or any summarization task, this will help you. Tree index, again, when you're going through some hierarchical data, you're summarizing a large chunk of document, you can use this. Composable graph, this will combine multiple indexes together for application like agents, right? So we have all heard of agentic AI. That is where we can start using these kind of index. And finally, all these pass-through index classes, index objects will be created. It's basically a structured data built from nodes and embeddings for fast querying. Then comes your retrievers, right? So here's where the magic actually begins. When a question is asked, retriever classes will look through those indexes and they'll fetch the most relevant nodes. Just like how a librarian will pull out the best books based on your query. Right? So based on what query I have, the librarian will go and pick up the best book, maybe a fiction novel that I'm looking for, right? These kind of things. So there are, again, different types of retriever classes in Llamaindex. You have vector index retriever, BM25 retriever, hybrid retriever, re-rankers, different kind of things based on what are the mechanisms backend. So vector index retriever, again, based on similarity search, cosine distance is what it will calculate. BM25 retriever, again, traditional keyword-based TF-IDF style it will do. Hybrid retriever, it will combine both vector and keyword methods. Re-rankers, they will use LLM in order to reorder the retrieve results based on the semantic understanding. And this is what probably the architecture looks like, right, of the thing itself. Then we also have query engine. Then comes the query engine. It will basically take the user's question and the retrieved chunks, and it will combine them in some sort of a meaningful way. So that the LLM can generate a coherent, accurate response. So again, what are the query engine components? You have engine from index. Again, these index are vector index, tree index, all that. Metadata filters, simple data filter, nodes can be used. LLM re-rankers, sentence transformers can be used. Prompt templates, okay? Different types of prompt templates can be used in order to get the ultimate final prompt to feed to the LLM. Then finally, everything comes together when the LLM will process this retrieved content and it will provide a human-like response. This is the end product that you see, the answers, the summaries, the insights. Okay, maybe all generated, these are all generated based on how well the system was set up. And finally, once the prompt goes, so the LLM via its API is going to wrap up the response, and the LLM processes the prompt and generates a natural language answer. And that is given to the user interface, and that's what you see. So this about wraps up the architecture of Llamaindex. It's basically a framework that makes it easy to use unstructured data along with LLMs in an efficient and scalable way. For more information, you can feel free to contact us, right? And you can keep following our webpage. I'll also head over to the code and we'll try and look into the Llamaindex framework. Okay. So let me begin explaining the code to you itself, code itself to you, right? So this is a common command. We're basically installing the necessary libraries. So we're installing Llamaindex, followed by that, we're installing, Hugging Face models. We're bringing the embeddings from there, LLM from there, sentence transformers from there, so on and so forth. Now, after installing the required libraries, we're basically, again, bringing the simple directory. So we're calling the simple directory to read all the supported files from the data folder itself, right? And it's the first step in the Llamaindex's pipeline, basically loading the unstructured data. And what we're doing is we're calling this simple directory reader so that each document which contains text or metadata, we basically perfect it for quickly testing out the document ingestion in a local folder itself. And from Hugging Face, we're fetching this mini LM model, L16 version 2 model, by giving the access to the token, etc. And we're also moving forward by putting in the model name, tokenizers, what exactly is the context window, how many tokens are we expecting, temperature parameter we're setting up, right? All of these things. And ultimately sequence to sequence model, because we wanted to map the output in a correct sequence. And we're setting up, the step 5 would be to set up the LLM and embedding model according to the global settings. And then the text document is what I've loaded. The text document is being taken, then the node parser will come into picture like we talked about. And from the node parser, we're bringing the sentence splitter. So we're basically splitting the sentence based on 256 tokens, right? So every time there is a 256 tokens, it gets split into different chunks. And then these nodes are going and we're basically using a vector store index, like I mentioned, different indexes, tree index, vector store index, etc., that we can use. So we're using the vector store index here. And we're creating a query engine, right? After that, we're asking questions to the index. So we can ask any question about the document. What exactly is the document talking about? What are the key points in this document? Can you summarize the document, etc.? And you can see the response. This is overall how the Llamaindex framework works. And these, so previously we talked about LangChain and now we talked about Llamaindex. So I would just quickly summarize that, the full pipeline flow of Llamaindex is such that first step is basically your loading. Okay. So you're loading the unstructured files, your heavy text documents, all of these are unstructured data. You're loading them. Then the next thing would be to chunk these loads, right? So you're chunking these huge documents into nodes using the simple node parser. Then you're doing embedding. So Hugging Face embedding we have used here. This will create vector representations. So all of these chunks, heavy text that you have, they're being converted into some vector numerical vectors, and those are getting embedded. Then we have indexing. Vector store index node that we have used here, it will build a searchable index, right? So that instead of going through the entire text document, it's going to go to the index. From the index, it is going to pick up and give you the retrieve the response. Then comes a query. So we've used retriever query engine. This will handle the semantic questions. Every time a question is asked, it will try to understand what is the based on the semantic similarity. It will go and search for what is the similar keywords and similar keywords present within the document, and accordingly the LLM will give a response. So this is about the Llamaindex framework. This summarizes the Llamaindex framework today. So stay tuned with us on the GenAI webinar. Previous sessions, we talked about LangChain framework. Now we're talking about Llamaindex, a lot more interesting frameworks that are going to come up. So please do stay tuned with us, and hoping to see you next time with more knowledge. Thank you so much.